Okay, so hello everyone. My name is Denis. I am a developer advocate at Couchbase. So we would like to talk a little bit. I would like to talk a little bit about databases, running databases on Kubernetes. Um, Essentially, I would like to start with a small tip for you guys. So whenever you are reading an article online, if the article starts with a question, the answer for this article is potentially no. Those are all real use cases here. So back in 2016, we have all those questions of people, all those articles actually, of people saying, should I run my database on Docker, or should I run my is a container database right for your organization? And those articles here are all from very reliable sources, and the conclusion of those articles were that no, you should not run your database on Docker. And back then, the main argument was that uh, containers are designed to be stateless. And yeah, that's true. Containers are in fact stateless. However, if we fast forward to 2019, essentially, you see that all those articles about the same topic are not questions anymore. So they are all, we even have something like running database in Docker at scale, which is the completely opposite of what we had just a few years ago. And the natural question is, okay, what have changed then? Why in just 3 years we completely changed our mind? And well, there are many things that happened during this time, but I would like to point a few of them that I consider the most important ones. The first one is, of course, now we have production grade images. So back then, when people first started running Docker databases on Docker, on containers actually, um, they were just creating those images by themselves, and the vendors haven't certified that, okay, we guarantee that you can run the database on Docker. So that was one of those things. Now I think SQL Server was essentially one of the last ones to release actually a certified um, Docker image. But now it's kind of a common thing. Every single vendor has their own official Docker machine. Of course, using Docker or containers is far easier to configure and set up than installing this on bare metal. You can also separate storage from compute, and from for some big data databases, that's a very good thing because you can scale you essentially have a huge storage, and you can upgrade and increase the size of your storage without restarting the database. So you have some availability there, and of course. Now we also have Kubernetes and stateful sets, which is essentially the core of this talk. One of the problems with databases on containers is actually that, well, databases are highly configurable, and you would you would it essentially requires you to generate a new image for every single configuration change you have on your database, and it's also a little bit complicated to ensure that all the databases are running the same image. So there is it's not um, just running the database on Docker is not something that is good enough. There is some missing parts. So one of the cool things in Kubernetes is that it is highly extensible, and we have something called custom resource definition. So let me come back here. First, let me increase the font size. Okay, so in Kubernetes, we have something called custom resource definition, which is this. thing here. So in this case, I'm defining a new custom resource definition here. I'm giving this name, and this is the group. And essentially, I say, okay, my new the kind of my new research is called to do. What I'm saying to Kubernetes here is, I'm saying, hey Kubernetes, there is a new type of research you should be aware of, which is called to do. Uh, in practice, what is happening here is something similar to creating a table. So I'm going to Kubernetes and saying, hey, there is this new table here to do that might have some variable, some attributes. And I have defined here the attributes, but yeah, essentially I'm defining a type here. And to do that, I will have to create a cluster resource definition. I have to do is to run control create minus f and minus f, and to do CRD here. And now I just created the new resource definition. And now if I want to insert data on this, if I want to create a new resource of the to-do type, or comparing this to a more backend developer thing, would be similar to insert a line on this table. I have here my definition and say my YAML file and say, and here I say, oh, okay, this new resource here is the to-do kind. It has a name that I have defined here, and the specs here are just attributes that I added here. So master speak at GOTO Oslo. And what I can do to just insert this data here on Kubernetes, I have to run kubectl create minus f to do YAML file. Okay, and the cool thing is now I can actually say kubectl get to dos, and essentially Kubernetes will return the to do that I have defined here. And if I run kubectl describe to do go to Oslo, I will see all the things that I have defined here. So here's the attributes that I have defined. So essentially, this is almost like using Kubernetes as a database. In fact, we are storing everything here on a database called etcd, which is the database that Kubernetes use. But what is really special about this thing that we just did is that I can actually store the whole definition of my database on Kubernetes, right? So instead of having the whole configuration, like generating a new image of my database every time, I can store the whole configuration of my server here, and then of course this doesn't change the fact that databases are stateful, containers are stateless, but at least now I have the whole configuration of my database inside Kubernetes. And then Kubernetes has something called operators. So operators are essentially applications that listen to events inside Kubernetes. And one of the cool things with operators is that it can listen to changes in customers in those definitions that we have created here. So if I create an operator for my to-do list, I could, whenever I insert a to-do list, the operator could hear this event that, okay, there is a new to-do, we just create a new to-do resource type. And then this operator could like get all the data that we have here, and then create a card on Trello, or create a ticket on Jira. So you can listen to the changes of those resources here, and essentially that's make this combination of operator and cluster resource definitions, something really powerful, because I can essentially uh, build an app that understands how to do some operations, deploy this in Kubernetes, and listen to those resource definitions and take some actions. In our case, um, now that whenever we add, let's come back here. So whenever we add a new resource with a type Couchbase cluster, sorry, let's go back here. Whenever I add a new resource type called Couchbase cluster, the operator could listen to this event that, okay, there is a new Couchbase cluster definition, and spin up the database with all the configurations we have defined. So essentially, everything now in Kubernetes will be added as most of the new features will be essentially a combination of resource, cluster resource definitions, and operators. And the cool thing is with this, yeah, this is just an example of how you can listen to events. So this is the code of an operator, and you can literally see that we have here an add event handler, and when a new pod is added, we handle this event here with some code. That's exactly what's going on inside the operator. You are literally listening to event changes in the cluster itself. And Kubernetes is an event-driven platform. So whenever you create a new pod, or a pod is deleted, or someone changes cluster a new resource, actually, it will trigger an event, and all the operators, all the applications that are extending Kubernetes can listen to those events. And what is really powerful about this when it comes to databases is that you can actually provide a cloud agnostic database as a service, right? Because first, um, you can essentially add a new, in this case, Couchbase cluster definition, and the operator that we provide. So Couchbase has built an operator for that. Um, so the operator that we provide will listen to this event and automatically provision a Couchbase cluster for you according to the configurations that you have defined. The second thing is it also can do some extra stuff, like if something goes wrong with the cluster, the operator is smart enough to see that, okay, something happened here, and let me fix that for you. So let's actually do this on our demo then. So first thing is, let me just clear my console and run control create -f Couchbase cluster. Okay, so now we just create our Couchbase cluster. Of course, it will take a while. So if I run kube control get pods minus watch. Oh, typo. Cool. Okay, so now we are already starting the first Couchbase node. If we see the definition here, Couchbase cluster, we see that, okay, this is the file I just this is the same file that I just ran here, Couchbase cluster, and you can see that, okay, in this file I already added all the cluster resource definition. I already have the operator running here. I'm just to save on time, but essentially what I'm doing here is I'm running Couchbase Enterprise 6.0. I have the whole configuration of here of how much memory I want for each service. I have failover here, so if a server is unresponsive for 30 seconds, we will consider that we will kill the server and start a new one. And here in buckets, I'm saying, okay, please create a new Couchbase, a bucket called Couchbase sample. The type is Couchbase. This is the memory. We have 3 copies or 2 replicas of of this bucket. So essentially, we have 3 copies of each document, just to be sure that if a server fails, we still have another replica will be promoted, and you haven't lost any data at all. So yeah, we have here CB example 001, 002 is almost ready. Let's do something else here. So I have, this is also a Java application. And this Java application, Couchbase has support for Spring Data. And I have a very simple app here. Let's see if I could see um, that this app essentially insert data. Yeah, here. So this app essentially insert data. I have a cron job here that inserts data on Couchbase every few seconds. And just I want to just show you guys that everything that we do, like while we recover the database, upgrade the database, we are doing this while the application is still live. So we are not losing any connectivity with with their application. So our your application reading to Couchbase is still fully responsive. So what we can do here is essentially let's kill this and say kube control create minus app spring boot app. So this will deploy our application as well, and this application is already connected to Couchbase. So if we run kube control get pods now, I guess that yeah, our application is almost there. At this point, our Couchbase cluster is ready. So let's connect to our database. So I can run here. Let's forward to my local machine, local port, and I can come here and say localhost 8080.1, and hopefully, yeah, here's this is the standard Couchbase web console. Okay, so first, here we have 3 servers. So the reason why we have this message is I specified that I have 3 replicas, but I would just have 3 servers, and which means that I only have 2 copies of the data, which is okay for this example. I would need to like 4 servers to at least have 3 copies of the data, of course. But here is the 3 nodes that I have here on my pod here. The other 2 things are actually the operator. So the operator is already running. You don't need to worry about the operator. It's just a YAML file that you download and run. So we provide the operator for you. And then the mission controller is actually just a way to validate your custom resource, your resource definition on Kubernetes. Just be sure that you're not inserting anything which is semantically invalid. So let's say if I made up some let's go back to Couchbase cluster. If I create something new attributed here that is not valid, when I try to insert this on Kubernetes, the admission controller will validate and throw me a message saying, "Hey, this is not a valid operation." So now that we have our cluster here, let's do just see one thing here. So statistics. Yeah, okay. So nodes running. Is our application running here? Okay, potentially because I forgot to run. Oh yeah, I have to run Spring. So kube control create minus app Spring boot app secret. So I forgot to actually add here the password that the application used to connect to Couchbase, and then here I can actually come to security and user Couchbase What is the name that I use again? So let's come back here. Um, it's pretty good at secret. So I know it's definition here. So Couchbase sample. So Couchbase sample, Couchbase sample, Couchbase sample, Couchbase sample. Don't do this at home. And okay, yeah, we should have um, our pod should be live soon. Yeah, that's it. So it's running now. Cool. Now we have our application running and everything's ready. Let's first create a bucket here. So I have my bucket, new bucket called test. Boom. And we have a bucket ready. However, yeah, the bucket just disappeared. The reason why this happened is because the operator makes sure that the configuration that we have, the configuration we have defined here is the same that you have in the database. So the operator makes sure that, okay, what we have here in the YAML file is the single source of truth. And if someone change anything here in the database that is not configured here, it will get reverted, right? Otherwise, that doesn't make sense to have this kind of thing at all because you can't really trust that this is the configuration you have in the database. So of course you can disable this, but by default this is enabled, and if you change something here in the control in the web console, it gets reverted by the operator unless you apply a new configuration. So that's the first thing. Let's go back to documents, statistics a little bit. So you see that our application is already inserting data in Couchbase. And if we come to buckets and documents, you can actually see that, yeah, documents. Oops. If we put documents, you can actually see some of the documents are just like random user. Okay, now let's make something super scary. So let's go back here and say crew control, delete minus f. Now delete pod, cb example 0002. Okay, so what happened here is we just lost one of the nodes of our database. This is where the DBA usually gets carried, and he essentially sits down and try to understand, okay, how can I recover the database? In our case, what we have to do to recover from this. So if you come here, you see that, okay, Couchbase noticed that, okay, this database is gone. So what we have to recover from this? Well, essentially nothing. That's the beauty of operators and Kubernetes. So of course, Kubernetes will bring this pod back because we have defined that we want three. Here in the YAML file, we have defined that we want three nodes. And now we just have two online. So Kubernetes, by now, actually, if we run kube control get pods, yeah, we already have here CB example 003. It's almost online. At some point, Couchbase will recognize here that there's, yeah, this just happened here. So now Couchbase recognize that we have a new Couchbase node. And the operator, again, here is databases are stateful, right? So when Kubernetes brought the node back, the operator listened to the event that, okay, there is a new Couchbase node, and then the operator called the APIs inside Couchbase to join the CB example 003 to this cluster that we have here. And of course, here we are essentially talking about the worst case possible, which is we are using ephemeral storage. So when you lose a node here, you're losing the whole data that we had in it, and the so the operator, as the operator knows that this is we lost the whole data in this node, in the node CB example 002. So the operator also calls a method called rebalancing, which is this button here. So it will copy data from those two nodes here to this server here. And it will evenly distribute the data between the servers, because when we add this new node here, as it is essentially without, we add this node without any data, and we need to distribute the load between those two nodes and this new one. So that's exactly what rebalancing is doing. Of course, rebalancing here takes a while because it is optimized for large a large volume of data. So it's not something that losing a node is not something that should be happening every hour. And quite often, when that happens, you are probably copying a few dozens of gigabytes. So that's exactly what's happening here. We optimize, we start moving shard by shard in this. Sorry, so we start moving shard by shard from those nodes here to this new one. That's what you're seeing in this graph in the top of the page. So essentially, we are moving each shard, and of course, one of the reasons we are very careful with rebalancing is when you have, like, let's say 3 nodes in this case, and you lose one, well, the other two will be responsible for we have to distribute the load between those two nodes that are still there, right? So we are very careful to not like copy the data from those two nodes to this new one as fast as possible, because you are already had downgrading performance here because you had 3 nodes and now you only have 2 that are available. And we make sure that, okay, when we add a new node and we start to rebalance the data, we have some clear limits on how fast can we copy data from those 2 nodes to this new one, to make sure that this will not make everything worse. So that's why it takes a while. And of course, whenever we finish to copy one bucket, we send a notification to the SDKs to update the cluster maps. So it is a truly distributed system happening here. And the good thing is we are essentially recovering from a failure without any manual intervention. So another cool thing here in Couchbase is actually the operator can do quite a lot of stuff. So for instance, if you want to upgrade from Couchbase 6 to Couchbase 6.5, for instance, all you have to do here is actually come here to the to the server definition and say, I want Couchbase 6.5 now. And then I can actually just come back here and say, control, create, replace -f Couchbase cluster. I'm not going to run this because I want to show this whole process finishing, but when I run this, it will essentially automatically upgrade the database for me. And again, the operator knows how to upgrade the database. If something fails in the middle of it, it will roll back to the previous version that you were. So yes, the operator can do this kind of thing. So other things that we can also do here is, if I want to, let's say I want to scale up my application, I can do something like this. So instead of having 3 nodes, I want to have 4 now. And in this case, yes, I can come back here and say control create -f Couchbase, replace in this case replace minus f Couchbase cluster, and let's wait. Oh, wait, yeah, that's that's one of the reasons why we need the um, admission controller, because it just noticed that okay, this is not a valid Couchbase version. So if let's save here and say okay, now I have 4 and control Couchbase replace. Now we are good. So now we are scaling up our database. Um, Here we already finished the rebalancing, and now at some point the CB example 004 potentially should appear here, and again the operator will make sure to rebalance again the data to be sure that we just move some of the shards in those 3 servers to the new one. Okay, so another cool thing in Couchbase, let's see here. So control get pods. We should see CB example 0. Yeah, here's CB example 004. Yeah, it's already here on the server. So another thing that is cool with Couchbase here in this case is that I can essentially I can boost adjust the application according to what I need. So let's say my application reads more than write. So if my application reads more than write, what I could do is something like, okay, I want 4 nodes of data, and then I don't know, maybe 10 nodes running index and query, and maybe I don't even need search, but okay, let's keep search here. Or if it is the opposite side, so my application writes much more data than reads, so I could have like 2 nodes here, and I don't know, maybe 10 nodes here. And if I do this right now, the operator knows exactly how to migrate from my current architecture to this one. And yes, I could define how I want, what's the configuration of the pod, like memory, CPU, and all the stuff. And here I could also adjust the hardware of the hardware requirements of this pod according to the service, right? So data needs more IOPS, index needs more memory, a query needs more CPU. So you can adjust the hardware as well according to the service you're running. Cool, let's go back. Yeah, so here, same thing, rebalancing here. So let's go back to our slides. Okay, of course, we need to talk a little bit about database as a service versus databases on Kubernetes. So Couchbase also offer database as a service. Essentially, which is called Couchbase Cloud, for instance, and essentially the Couchbase Cloud is the operators on Kubernetes running on the cloud with some extra features. And that is essentially how it also worked with other cloud providers. So they pretty much have been using Kubernetes for their cloud offer. And yeah, the cool thing about the database as a service in general is it's usually easy. So it's really easy to start. You have some cloud providers, you have a very low TCO, and sometimes you even have a free tier, so you don't even need to pay anything for the database as a service. But quite often you kind of it lacks a little bit of flexibility, essentially because um, in order to bring the cost down, they have a shared architecture. I think a Couchbase Cloud now is private servers, private clusters, so nothing is shared. But most of the database as a service solutions, they try to share servers to bring the cost down. So the best in general is really good when you have like small applications. Otherwise, it gets very pricey. And database on Kubernetes, I would say that it is. I would dare to say that it will be the potentially will be the default choice in the future. Essentially because you can have a fully managed database on your own um, data center or on your own infrastructure with the same flexibility that you still have on bare metal. So in this case here, you can still adjust the hardware according to the service you are running. But yes, nowadays it does require some a little bit of knowledge of Kubernetes itself. So if you're already done running Kubernetes, if you already know Kubernetes quite well, that might be already a good choice for you. Yeah, here since last month we have now Couchbase Cloud, which is our operator running on AWS on all the cloud providers with some extra features. And as we are talking about databases, we also have to talk a little bit about storage in general. So, in our case here in our demo, we have been using ephemeral storage, but most databases, Couchbase included, also support remote persistent storage and local persistent storage. Um, Local persistent storage actually is GA from since Kubernetes 1.14, so not that it's just it was launched essentially GA last year, so still something get that it is still something getting more popular now. But it's important to say that local persistent storage is not a general purpose storage, essentially because first, you are with local persistent storage. Whenever the pod fails, if the pod dies for some reason, with local persistent storage, the scheduler in Kubernetes will try to schedule the same pod in the to run the same node again in the same worker, and it kind of you are essentially attaching the pod to a node, which might not be the best approach in Kubernetes. Ideally, we should not even know where things are running. But in this case, because we really databases are very disk intensive applications, well, that really makes sense. So for databases, it's okay to run local persistent storage because you have nearly the same performance that you get on uh, on traditional disks on bare metal. Um, of course, local persistent storage because the disk is not a storage, is just a direct access to the disk. You have lower availability because at some point this disk will might fail. The data is not replicated, and at least till this point, it local persistent storage still requires some node or disk preparation. But in general, it's okay for to run databases on local persistent storage because pretty much all databases have some sort of replica of the data, and if the disk fails, you still have um, the data somewhere else, so it's not a big issue at all. This is just an example. So hostpaths is kind of a hack of how we did local persistent storage in the past. And now essentially everything should you should not use host paths anymore. Pretty much everything should be moved to local persistent storage. Local persistent storage use the same framework that the same approach that remote persistent storage. So you still have the portability, accountability, stateful sets, all those sort of things. And of course, I think we should also talk a little bit about benchmarking. So When we talk about running databases on containers, we need to think about, okay, what's the side effect of that? Do I have any performance issues? And essentially, we tested that, and there is this Yahoo serving benchmark that you saw in the previous slide. And yeah, we saw some changes in performance that really depends of which kind of workload you're doing. So in Couchbase, because we have a lot of caching, if you're using like a workload A, for instance, so 50% reads, 50% writes, we saw no difference at all between containers and bare metal. While in the workload E, where you have like a short range of records, we saw a performance penalty of up to 10%. So next slide essentially show you here. So here is performance of less than 1%. Here doesn't make any difference here on workload A. In fact, the container one even had some better performance. But here you see the workload A in the worst use case, we have a delta of almost 10%. So this is the benchmark that we did. So I suppose that this should be the same for other databases as well. So whenever you're running database on Kubernetes, make sure to add some extra CPU if possible or memory to to address this performance downgrade. In our case, worst case, if you have a lot of servers, make sure to add an extra node just to compensate for potential performance penalties. Okay, last thing here is operators now is already a big thing in Kubernetes. There is this website here called the Operator Hub, where essentially the folks from Red Hat store kind of create a catalog of all the operators out there. So you guys definitely should check it out. And well, there is already, and of course, there is operators for other databases as well. There's some cool talks on the previous KubeCons talking about how they have built operator for MySQL and for Postgres. So I definitely recommend you guys to check it out. And well, I really appreciate if you made to the end of the video. And thank you. If you have any questions, feel free to ping me on Twitter. I will, for sure, I will come back to you with the answers. And yeah, I hope you like it. So see you next time.